Okay, going back here to the first slide. So we're now going to study moon phases, and this is very important because, well, it's very important for us to understand when we look up and see the moon, what are causing the different phases of the moon. What causes it to look like a crescent moon, what causes it to look like a full moon, etc. But this has been important for a very long time because moon phases were our first calendar. So this was a way of marking time, right? If you looked up in the sky and let's say you saw a nice full moon like that in the picture, um, if you just waited about 30 days, you'd see another full moon. And you could mark time by what phase the moon was in. So it was very important to early humans. Obviously, something that you could see very easily. It's very big in the sky. And so we want to understand what causes those phases in more detail. Well, it's all about geometry. And in this picture, what you can see is that the sun is coming from this, sunlight's coming from this direction. And you're seeing the Earth here, moon at different positions in its orbit around the Earth, and which phase the moon is in. So this is new moon, even though it shows there's some light on there, that you wouldn't see anything. We'll see that in another picture. Let's look at a different diagram here. So in this diagram, it's a little better because they're showing you, well, there's no moon to see during the new moon because the sun's over here and the sun is illuminating sort of the back side of the moon and there's no illumination for you to see. Whereas if you look at the full moon over here, right, actually it's a waxing day, but here's the full moon. So you see this along this line, right? The sun is illuminating this whole surface here, and it always illuminates that surface, but it depends on where the moon is in its orbit around the Earth. The girl here is representing the Earth. That depends on, so what we see depends on where in the orbit the moon is. So let's look at a simulation. This will make this a lot clearer. All right, so we're starting here on the new moon. And just to explain this simulation a little bit, here's the phase. Now, of course, you wouldn't really see this. You would see nothing for the new moon, but they put that up there. So to represent the new moon, and this is the phase. And when we start the simulation, we can move this person, right? So we can move forward an hour, let's say, and see what happens. It's starting to be dark, right? Sun setting. And over here, notice that we see representations of both the sun and the moon. Can't really see that. There's the sun, there's the moon. Obviously, the sun is not in front of the moon in this phase, right? So here's the sun over here. And if we look from our point of view, right, there's the moon and then the sun over here. Okay. But that's just a representation here of when it's going to rise and set. Okay. All right, so let's just start the animation and see what happens. Okay, so here we go. Moon is moving. Look at what's happening here. Light is starting to creep in on the right. Let's pause the animation. Now I'm going to move him over just by a little bit. Okay. All right. So now he can see the moon. Notice that when he was over here, look, the moon has set. Look to this part over here to see what's going on. So the sun has set. Let's go back. Let's let the sun come up again. Here's the sun. Sun sets. Now you can really see the moon, right? Okay, so now you can see the moon, and if he looked up and saw the moon, he would see this. Light sort of creeping in on the right-hand side of the moon. And notice that I want you to really pay attention to the fact that half of the moon is illuminated by the sun. That never changes. It's just how much of that illumination do we see when we look up at the moon, okay? So you can see that just because of where it is in its orbit, when we look up, we only see this little sliver, which is kind of represented right here. So if you look here, imagine looking up, you would see this little sliver on the right, okay, right here. All right, let's keep going. All right, here we go. We're heading towards our quarter moon. Here we go. Let's get to the quarter. Right there. Okay. Oh, I gotta go back just a tiny bit. Let's go back a day. Nope. Too long. Too much. Okay, this is annoying. Oh, that's like really annoying. I just messed that up again. All right, let's try that again. All right, let's go forward. Okay, good enough. Okay, so now, first quarter. This is called the first quarter, right? Because we started from the new, and then we're getting to a quarter. Now, notice again, always, the moon is, there's half of the moon that's illuminated by the sun. So if you took a little rocket and you were like circling around the moon, you'd see half of it was bright and half of it was dark. But when we look up from our vantage point here, and let's let this be night so that he can see the moon. There it is. Right, here's the moon, sun just set. We see half of it illuminated, and it's the right half when it's the first quarter, and we'll see that changes. All right, let's run. Okay. All right, getting fuller and fuller and fuller. Okay, getting there. Try to stop it right when we get to the full 100% illuminated. We'll go forward an hour. There we go. Now, the sun has set a little while ago here, right? So, and the moon is right above the person. I don't know if you can see that here. I can sort of drag it around. Oops, I didn't want to do that. Don't do that. Okay. So if we go forward, go backwards a little bit. Right, let's let the sun be up a little bit. There. And now as we go forward, the sun sets and the moon rises, right? So they sort of chase each other. And now we have full moon. Notice again, half of the moon is illuminated by the sun, right? But we're seeing that whole half. And when we look at the full moon, this takes a little getting used to, okay? And now what's going to happen is that we're going to start seeing less of this full half as we go forward in time. Here we go. Now notice there's a little bit of dark creeping in from the right. Let's get to our third quarter in a second. Okay, that's about right. Oh. There we go. This is the third quarter, and you can tell it's the third quarter because it's the left side that's bright. And notice, again, half of the moon is illuminated. We just can only see, right? We see sort of a, you know, a little half and half here, right? If we looked straight up, right now, of course, he can't see the moon because it's not dark, but I can sort of let him see it. There we go. Okay, now it's dark and he can see the moon. And he would see half dark and half light, even though half of the moon's surface is being illuminated by the sun. Okay, so now as we start again going towards the new moon, less and less of that half illuminated part we can see. And this thing here is just telling you how much of the illuminated part of the moon we can see. Okay? All right, that number. All right, let's see our little crescent. All right, so here, this is called a waning crescent. You can tell that it's waning, which means you're going towards the new moon because you get the light on the left. Okay, so that's a waning crescent. Waning means they're getting smaller. And now let's go over to where we had the waxing crescent, and notice the light is on the right. So now you can tell when you look up and you see a crescent moon, if the light's on your right, you're heading towards the full moon. If the light's on your left, you're heading towards the new moon. Okay, no moon. Okay, it's a useful thing. Okay, what else want I to tell you about this? I think we can go back to the PowerPoint. Hello, PowerPoint. There we go. Okay, and let's take a look at the phases. So again, we were just looking at this, right? When you have waxing, you have light on the right, also in the full first quarter. The gibbous, that means it's kind of like a dark crescent, right? You got a dark crescent, the gibbous moon. And this is a waxing gibbous, even though we don't write that down here. Then you get a full moon, and then you get a waning gibbous, which means that the light you see is getting smaller and smaller. Again, on the left, you can now tell which is which. Okay, so let's try a question. All right, again, you're going to have to pause the video and think about this geometry here. Read the question, answer pick the right answer from below.